Okay, so we're going to look a little bit more at what we can do with logarithms today. Um, you may see a problem like this, and right now the x is not by itself, correct? Okay, so maybe we could switch it to exponent form and see if that would change anything. What would this be if we rewrote it in exponent form, thinking back to our last lesson? 9 to the 3 halves equals x. Okay, let's solve this by just changing it to its base number, which is 3 squared. If we multiply these guys, what do we get? Okay. What is 3 to the third? 3 times 3 times 3? 27. Okay. Alright, this one we also don't have x by itself, so we could try switching it over to exponent form. What would this one be? Okay, so we're just rewriting it in exponent form. Remember, it's always this thing raised to this power equals whatever is there. Okay, how would we get x by itself in this situation? Because it's not alone right now. We need to raise it to something. Somebody said it. To the 2/5. You need to do the reciprocal. So we take this to the 2/5, this to the 2/5. Because if we multiply these, what do we get? We get 1, which is just x, or x to the first power. Someone punch that in their calculator for me. I believe it's a decimal. Questions on that? No? Okay, so you're going to have problems that look like that, where you're just going to switch it to exponent form and then solve for x in whatever way you need to. Might be like the ones on the left, might be like the ones on the right. And then you may have problems like this, okay, where you have a log on both sides. If it's the same log with the same base number, right here, if these are the same, then these are the same. Okay, so you just drop the logs and you focus on these being equal. So if you have a logarithm on both sides and they're both the same logs with the same base, you can ignore those and just focus on the variables. So if we have this, how would we solve for x on this problem? Good guess, but we're not going to divide by 2. Minus and factor. We're going to subtract this one over here. X squared minus 2x minus 15 equals 0. So we draw our x. What goes on top? Negative 15, negative 2. What two numbers work? We need to multiply to this, and they need to add to be this. Negative 5 and 3 works. Do we have to do the window step? No, because there's no number out front here. So these are our two numbers that go in the parentheses. And now we actually need our two answers. So how do we do that? Yeah, we set these each equal to 0 and solve. So this one would be 5. This one over here is negative 3. Now, like it says over here on the right, we need to make sure that these numbers actually work, because this, whatever this is right here in the logarithm, cannot be 0 or a negative answer. So we're going to have to check both sides. We want to put both numbers here, and we want to put both numbers here to make sure we don't get 0 or negative. So if we put a 5 right here, do we get 0 or negative? No, we don't get 0 or negative. What about on the right? Okay, so 5 works. What about a negative 3 on the left? Do we get 0 or negative? Yeah, we get a negative number. If we put a negative 3 over here, we definitely get a negative number as well. So this one does not work, and we only use the 5. Sometimes both numbers will work, and you can have both of them. So you need to make sure you check that. Questions?